In this recording, we're going to review the essential skill parent graphs for integrated 3. So I've written some of the parent graphs on our screen. Notice that A shows up in almost all of them, and that's because it does the same thing to all of our graphs. So down below, I talk about A. A is the stretch factor. If A is negative, then we say that the graph has been reflected vertically. Now that we've dealt with whether it's positive or negative, we just look at the absolute value of A, so the actual number itself. If the absolute value of A is bigger than 1, then the graph has been stretched vertically. If the absolute value of A is less than 1, then we say the graph has been compressed vertically. Then if you look at our graphs, you'll notice they almost all, well, they do all, have an x minus h in the equation. The x minus h is our left and right shift. So when it says x minus h, you kind of have to think about it backwards. You do zero product property, and it kind of does the opposite of what you would think it does, but we'll talk about that on another slide. Finally, the plus k at the end, that's our vertical shift. It shifts up or down, and it's true to the number you see. So if you see plus 7, it's going to go up 7. So on our next slides, we're going to actually graph a few of these. So parabola. For our first equation, the first thing I want to do is write down what the vertex would be. When you're finding the vertex of the parabola, you do opposite what's happening in the parentheses. So I see x minus 3 in the parentheses. That means my vertex x value is actually positive 3. And then you keep k the same. So I see that there's a plus 1 for the k value. The vertex y value is plus 1, just like it says in the equation. So that's the first point I'm going to plot. 3, 1 is my vertex. Then we look at our stretch factor, our a value. In this case, a value is 2. So the vertical stretch of our parabola is going to be 2. Since it's positive, we know it's opening up. And each point, exactly 1 away from the vertex, needs to be stretched 2 higher than the vertex. So 1 point to the left is 2 higher, and 1 point to the right is 2 higher. So now I have my other 2 points, and that's enough to sketch in a vertically stretched parabola. You're also going to be required to name all the transformations. So let's just go through in order. The 2 in the front made it stretched vertically. The x minus 3 in parentheses, remember that gave us a vertex at positive 3, so that's right 3. And then the plus 1 at the end, remember that moved our vertex up 1, so transformation up 1. Now's a good time to pause the video and see if you can name the vertex and maybe even get a sketch of number 2 going. So pause the video, and then when you press play, I'll have done my vertex by already. So hopefully you were able to find your vertex. It would be at -2, -1, because I did opposite what was happening in the parentheses, and then k stayed the same. So that's the first point I plotted. Then remember, your stretch factor tells you about the points right next to the vertex. It is not a slope. It's always 1 away from the vertex. This case it's negative, so we know it's going to be opening down, and it's only going to be halfway down from the vertex. So they're not going to be precise, but I try to plot a point on both sides of my vertex that's half a unit lower than the vertex. And then I try to sketch it to look like a wide parabola. Don't use straight lines, make sure your parabola has a curve to it. Now see if you can name the transformations. Here's a hint. The yellow is going to give me 2 different transformations. And then, of course, the pink will give me one, and the green will give me one also. See if you can pause the video and fill in the transformations. So this time our A value was negative. When you have a negative A value, the graph has been reflected vertically. This time our A value, the absolute value of our A value was just 1/2, which is a number smaller than 1. When it's smaller than 1, it's compressed vertically. It moved left 2 and down 1. Now we're going to put this into practice for other parent graphs. Cubics. So we start by the same process, but it's not called a vertex. We could either call it a locator point or an inflection point. But you find it the same way. So you're still doing opposite of the one in parentheses, comma, k stays the same. So our locator point or our inflection point is 1, -2. In a cubic, that point is called an inflection point. It's where the graph changes concavity. We'll talk about it when we go to sketch it. So 1, -2. Then, let's see. There we go. So our stretch factor is positive 1/2. So for cubics, if it's positive, it's going uphill. And we're still looking at the point right next door to the locator point. So since it's 1/2, I want to go right next door and go only up 1/2 a unit. And then right next door on the other side, I want to go the opposite direction, so down 1/2 a unit. You'll notice your 3 dots look like they can make a straight line, but remember they're supposed to make a cubic, so it kind of looks like a wide 1/2 of a parabola going up, and then it changes to a wide 1/2 a parabola going down. Where it changes concavity, that's called your inflection point. So see if you can label the inflection point, which I'm going to call IP now, on the second one, and get your graph going. And then we'll go through and name the transformations. So first I noticed I was missing the cubic, so I put the little cube on the graph, the equation. So inflection point opposite, so -2, and then it stays the same, +1. -2, 1 is your inflection or your locator point. Then this time the A value is -3, so my cubic's going to be going downhill. The point to the right needs to be 3 lower than the vertex, or I'm sorry, the locator point. And the point to the left needs to be 3 higher than your locator point. So if you look at these 3 dots, it looks like it's a line going downhill. But I need to sketch it in to look like a cubic. So try to make it look like 1/2 of a parabola going down, and then it kind of looks like 1/2 of a parabola going up. Okay, now we need to name the transformations for all these graphs. Doesn't even matter what the graph is, you should be able to look at A, H, and K and label your transformations. So I'll give you a hint. On the first one, the yellow gives me a transformation, the pink will give me a transformation, and the green will give me a transformation. On number 2, the yellow is going to give me 2 transformations. Pink will still give me 1, and green will give me 1. So pause the video and see if you can come up with these transformations on your own, and see if you're catching on to why sometimes the yellow gives me 2 and sometimes it only gives me 1. Okay, so for number 1, A was 1/2, so compressed vertically, right 1 and down 2. For number 2, because A was negative, that's the part that gives me an extra transformation. The negative made it reflected vertically. Because it was 3, it was stretched vertically, left 2 and up 1. So hopefully you're catching on to how A, H, and K change your graph. Absolute values. See if you can find the vertex of these absolute values. So A, H, and K. H and K give me the vertex of both of these. So now let's look at number 1. For absolute value, you plot the vertex, 1, -2. And absolute value is the only parent graph where you can actually use the a value as a slope. So 2/3, rise over run, up 2/3, repeat, up 2/3. And then it's supposed to look like a V when you're done, so up 2/3 the other direction, and repeat up 2/3. And try to sketch it in to look like straight lines that make a V. I kind of missed that dot, but you get the point. So let's see if we can graph number 2. Vertex -3, +2. Absolute value, the only time you get to use it as a slope. So negative means down. Down 3/1. Repeat, down 3/1. Same thing to the other side. Down 3/1, down 3/1. Try to make it straight lines that make a V shape. Now see if you can name all the transformations for these graphs. Just look at the equations, look at the highlighted parts, and see if you can come up with all the transformations. Pause the video and see what you can do. Okay, so 2/3 is less than 1, compressed vertically. Write 1 down 2 for problem 1. For problem 2, that negative gave me an extra transformation reflected vertically. It's 3, which is bigger than 1, so stretched vertically. Left 3, up 2. Exponentials. This year, chances are the base of your exponential is going to be a 2. But if the base is anything else, it really doesn't change the graph much other than the curve is a little steeper. Okay, so for our first exponential, the first thing you want to find is the asymptote. You should remember that exponential graphs have an asymptote. The asymptote is always going to be at your k value, and that's y equals your k value. So in this case, y equals -1. That's the first thing I want to graph. So I'm going to graph it in green because it's my asymptote and I highlighted it in green. So y equals -1. Always graph your asymptote as a dotted line. It needs to be included in your graph to get full credit. Then we look at our h value. Remember, our h moves it left or right. So since it says +3 in parentheses, we should be catching on that actually means left 3. And then the a value tells me, and there's an imaginary 1 in front of this graph, right, in front of this equation. The a value tells me how many units above the asymptote my locator point is. So I'm going to go left 3, and I'm going to make sure my point is 1 higher than the asymptote, which actually puts the point here at -3, 0. Now I know my locator point is -3, 0. Then we sketch it. There's no negative sign, so it's going to hug the asymptote and curve quickly up and away. Let's work on sketching number 2 before we do transformations. So start with your asymptote. I want you to pause the video and see if you can correctly name and graph your asymptote. So hopefully you got your asymptote at y equals 3. Then if we look at h, we're going to go 1 to the right. But then if we look at a, our point is going to be 2 lower than the asymptote because it's -2. So 1 to the right from 0, 2 lower than the asymptote puts my locator point here. Then, since it's negative and since my dot is below the asymptote, we know it's going to hug the asymptote. It's not perfect, but you get the idea. And curve down and away because it's been reflected vertically. That's going to be one of our transformations. See if you can go through and name the transformations for these 2 graphs. So the first graph was moved left 3 and down 1. Our second graph was reflected vertically because of the negative, stretched vertically because of the multiply by 2, moved right 1 and up 3. Okay, hyperbola. First thing you want to do is find your locator point. Finding it the same way as we have been in the past. Opposite of x plus 2 gives me -2. And then the k value, the constant at the end, minus 4 stays minus 4. For hyperbolas, this gives me the location where our asymptotes cross. So -2, -4 is going to be our locator point. That's where we have a vertical asymptote and a horizontal asymptote that cross. Then we look at A. Since A is positive, we know it's going to be in the top right corner and the bottom left corner. The 3 makes it stretched vertically, so it pulls it a little further away from the locator point. But we're just looking for a sketch in integrated 3, and the important part is putting it in the correct quadrants. So +3 means it's going to go, like I said, top right, hug the asymptotes, try not to cross them, and bottom left, those 2. See if you can get the locator point and a sketch for problem number 2. So locator point for number 2 would be -1, +2. That's where you draw your vertical asymptote and your horizontal asymptote. Draw them as dotted lines. Then because this one is negative, it's in the opposite corners of problem 1. So it's in the top left and bottom right quadrants. Just a sketch. See if you can name all the transformations for both of these graphs. Pause the video and see if you can name all the transformations. Okay, go ahead and check your answers. Square root function. Same idea. Locator point also could be called a vertex, but let's stick with locator point. Opposite of, it's not visibly in parentheses, but it's assumed to be in parentheses. So -1, and then k stays the same. -3. That's our locator point. Then our a value, yellow, sorry. Our a value is -1/2. So the point 1/, should be down halfway. Sorry. So our square root looks like this. Let's do locator point for number 2. Locator point 2, 1. The a value is 3, so my vertical stretch, when I go 1/, it's 3 higher than the original point. So it has a pretty big stretch, and then it curves out to the right. See if you can name the transformations for both of these graphs. And then go ahead and check your answers. Okay, the last type of graph I'm going to talk about is the circle. Be expected to need to put circle in graphing form on your own, so that's what we're starting with first. Here's my equation. I'm going to organize it so that the x's are next to each other. So I'm just rearranging. I'm going to leave some space there, and then I want to put the y's next to each other. And then I'm going to move the constant, any constants, to the other side of the equation. I'm still going to leave some space, but now I know my equation equals 4. So this is completing the square. You might know how to do it a different way, and that's perfectly fine. What I have my students do is add a square to the first variable, and then I'm going to add a different shape because it represents a different number. So I'm going to add a triangle for the y's. To keep my equation balanced, that means I have to add a square and a triangle to the other side of the equation as well. Completing the square, I take half of the number with x, so 2 divided by 2 is 1, quantity squared. That number squared gives me the empty square, which is 1. Add it to both sides. Same idea with the y. Half of the number with a single y, so negative 4 divided by 2 is negative 2, parentheses, squared. That number squared happens to be 4, so the triangle is 4. Then I add the numbers on the right, 4 plus 1 plus 4, it equals 9. Now we should be able to answer a couple questions. Those would be the center and the radius, and we should be able to sketch it. So notice both of these are in parentheses. So the one I keep making pink, h, we still do opposite of that, so negative 1. But now the green one is in parentheses also, so we have to do zero product property with that one also, and now it's positive 2. So our center is going to be at negative 1, positive 2. And then our radius is going to be the square root of 9, which is 3. See if you can sketch this circle. Point at negative 1, 2, and then 3 in every direction. 3 to the left, 3 up, 3 to the right, 3 down. Try to make it look like a circle. Okay, last thing being covered in this video is being able to go backwards and come up with the equation based on what's given. So don't forget to use the equation they want us to. So make sure this one is a cubic, make sure this one is an absolute value, and make sure this one is a square root function when you're all done. So y equals, or f of x equals is even better, but either one is fine. We know it's going to be a cubic, so I'm going to set it up. In general, I'm going to fill in some gaps here. It says it's shifted 2 units left. Remember, left, right is our h. In order to be 2 units left, it must have been plus 2, because it's kind of opposite of what you think in the parentheses. It says 4 units down. Remember, k is our up, down. So if it's 4 units down, it must be minus 4. And it says it's compressed vertically by 1/2. So I literally put a 1/2 in the front. See if you can do number 2. So I set it up to make sure it's an absolute value function. Reflected vertically. Reflecting vertically means our a value is negative. Stretched vertically by 3, so now I know our a value is negative 3. Right 2, so my parentheses or my absolute value needs to say minus 2, and then up 7, so my k value needs to say plus 7. I'm going to fill in all of number 3. Pause the video and see if you can get number 3 correct. Okay, there's my final answer for number 3. Compress vertically by 1/3, left 2. Make sure this 5 at the end is out of the square root sign, like minus. Hopefully this helped you with your essential skills parent graph.